This lecture here is going to be on projectile motion. Now, we've already covered a lot of distance in what we've been studying so far, but let's just make sure we have a chance to go over this again. Vectors and vector diagrams that we do in class imply that you understand what is we call the unit circle or the coordinate plane system in regards to the degrees associated with direction. So here we've defined east is 0 degrees, north is 90, west is 180, and south is 270. And when we complete the circle, 360 degrees also represents east. So really 0 is this quadrant right here, 0 to 90 degrees, 90 to 180, 180 to 270, and 270 to 360. Velocity vectors. A projectile that is launched has both x and y components. The x component is staying constant. If you look at the picture, the blue horizontal or velocity vectors are constant. They're equal in magnitude and in size. There's nothing changing about them. This is the velocity acting in the horizontal direction. There is no force acting upon it, so its motion does not change. Right? Our last unit we learned that if a force is acting on it, something has to change, but there's no force acting horizontally. The y component is changing. This is because gravity is acting upon it. Therefore, it is changing. As it travels upward, it's slowing down. At the top of its flight, it stops instantaneously before speeding up as it travels downward. And you'll see that the magnitude changes. It gets smaller on the way up. Technically up here it's 0. And then it changes direction as it's traveling or speeding up downward. So notice, at this point right here, in this point right here, they should be equal in magnitude but opposite in direction. And the same as my starting velocity vector here should be equal in magnitude but opposite in direction for the ending point of this location right here. In some related terminology, a projectile, this is an object that is being affected only by gravity. The parabola is the shape of this. Any shape of an object that is being launched is a parabola. The trajectory is simply the path that the object takes during its motion. The range is what we would call the distance in the x direction. And the height is what we are going to define as, well, the height in which the projectile went is what we're going to call d of y. So let's make sure we understand what is projectile motion. Well, if I look here at number 1, dropping an object straight down only has a y component, or v of y. This would not be projectile motion. This would just be one-dimensional motion. But if you toss an object upward at a non-90 degree angle, it has both x and y components, right? So this one right here, it doesn't have a whole lot of x, but it does have some x components. So this would be two-dimensional motion. It's traveling in both the y direction as it's traveling in the x direction. Obviously, x is a lot less than the y. And then number 3, tossing an object with an even smaller angle illustrates that that the v of x in this picture is larger than the v of x in example 2. Right, so my v of x here it's going to travel the greater distance in the same amount of time. So therefore, my v of x must be larger. Notice they travel to roughly the same height, and I think the picture is trying to show that it is the same height. But here it travels a greater distance in the same amount of time. Therefore, it has a greater v of x. So we can see this visually. Projectile motion is 2 dimensions of motion, and we call this x and y. So here's two-dimensional motion, or here's the trajectory of the two-dimensional motion object. This is the trajectory of this two-dimensional object, and this would just be one-dimensional motion where just gravity is acting upon it. So let's look at this picture here. So when we launch an object into the air, it involves 2 parts. These parts are called the components. And these are what we call x and y. The resulting velocity of the object being launched is the result of the x and y components, right? This is what we call the resultant. So observe the ball that is being thrown up into the picture. If gravity did not act upon it, it would travel in a straight line. This would be its inertial path. If there was no gravity acting this way, it would just keep on traveling in this direction, just like the hovercrafts in the hallway. So in the direction of the resultant velocity, right? So that's what we looked at in the picture. But gravity is acting upon it, so its path changes according to the force acting upon it. And gravity is acting downward, so its path is going to change as a result. So here's something we can look at. There's a couple different ways that we can view 2D motion or projectile motion. This is just a ball traveling off a table. If you notice, this is just half of a parabola, but it's still nonetheless two-dimensional motion. So here's an example. It's got a 5 meter per second horizontal velocity. Notice the velocity is staying constant. So the v of x is staying constant at 5 meters per second, where the v of y is actually increasing. So the size of this arrow is getting larger as it falls. It's traveling a greater distance in a unit of time. So the picture to the left it would be an upward launch or something where we get a full parabola. But this is two-dimensional motion. It's just not a full parabola. It'd be just a half of a parabola. So make sure you go back through the lecture slides and read these. There's a lot of information here. So let's take a look at a little more complex conceptual projectile motion. So this is kind of a funky person who throws a ball. So let's say they throw this object and it travels up and down. I'm just tracing its trajectory. And it travels here. So observe the picture above. The student tosses the ball into the air at an angle and gravity begins to alter the motion. Gravity acts only in the y direction. So only the y component changes. The x component remains unaffected. At the top of the projectile's flight, the v of y is 0 meters per second. So we're going to go over this. We're going to go through this. So we're going to observe letters A, B, C, D, and E in the picture. So as soon as they toss, this student tosses this ball right here, it has this is the resultant velocity. But the resultant simply tells me it has a velocity in the x direction and a velocity in the y direction. But the velocity in the x direction is going to stay constant throughout the entire object's flight. It's the v of y that's going to be changing. As it travels upward, the magnitude is going to decrease. At the top, there's going to have 0, right, a velocity of 0 in the y direction, and then it's going to continue to speed up on its path downward. And then here, at the point at which the person tossed it, it's going to have the same v of y. It's going to have the same magnitude, but they're going to be in opposite directions. So here, its velocity would be negative. But notice, I gave you an extra point f here, just to think about this. It's traveled further downward, so it's going to have a greater velocity in the y direction. So I think what we're looking at here, what you need to keep in mind is that it's only the y component that's changing. Your x component, your v of x, is going to stay constant. And this just further reiterates that a little bit more conceptual. So here's where you come into play, and you're going to go ahead and start watching these videos. Here's a class video. You'll want to watch this. We collected some actual data, and you'll have a chance to do some problem solving. And I recommend you take these seriously. We've got v of x equals d of x divided by t. We've got v of y equals g times 1/2 of total t. Your launch velocity and angle is going to simply be the resultant velocity of your v of x and v of y. And your d of y is going to equal 1/2 at squared, or 5t squared since we are on Earth. Here's another problem. This is a 7th period class. We're going to do the same type. I just want you to get some practice here where I'm really just throwing you in the mix. And last but not least, here's some more practice problems. I give you a little different set of numbers to work with, and here's the answer key. So good luck and have a wonderful time solving physics problems. Woohoo!